Thank you very much. And now let us begin with the keynote speeches. For our first keynote speech, we have a special guest joining us online from the United States. We have Professor Ruslan Salahutdinov from the Department of Machine Learning of Carnegie Mellon University. Professor Salahutdinov will take us through an insightful keynote speech about building embodied autonomous agents with multimodal interactions. So please welcome him with a big round of applause, ladies and gentlemen. Good morning, sir. The floor is yours.
Thank you so much. Can you hear me? Is everything okay on the floor? Well, thank you very much for the invitation. Let me just share my screen and just get my connection working properly. 1 second. Great. Can you hear me? Thank you very much for the invitation. I wish I could be there in person. Unfortunately, I couldn't make it this time, but hopefully I'll be able to visit Korea next time. So today I wanted to talk about some of the cutting edge research that we do at CMU, as well as our collaboration with a number of companies. But before I start, getting into specific details, I wanted to, mention that we're sort of living in a very interesting times where AI is sort of developing so quickly, and it's very exciting to see all the recent developments that we see in that space. So if we look at computer vision, we now have foundation models that can reach human level performance in terms of recognizing objects. Speech recognition is getting close to, or better than the human speech recognition. Reasoning and planning, we all remember the game of Go that was developed by Google DeepMind. Language understanding, as was mentioned in one of the introductory remarks, GPT and ChatGPT models have shown remarkable abilities in terms of understanding natural language. And robotics, we see a lot of progress in robotics, and part of the talk today we're going to focus on robotics applications. But if you look at self-driving cars, robots, we sort of see again this amazing evolution of that technology. And a lot of it has to do with machine learning and data. We've been able to develop algorithms, but the key driving force behind pretty much all the recent developments is the data, large volumes of data. Again, if you look at perception and 3D scene understanding, we're reaching to the point where we can be very accurate at recognizing objects and doing scene understanding. Conversational agents with ChatGPT models, that's now becoming a reality. 2 years ago, nobody would have thought that we could develop systems as good as they are today. Recommendation engines, machine translation systems. One area of research is medical image analysis, and we're seeing a lot of progress in sort of drug discovery and medical image analysis, and of course self-driving cars. That area sort of has been growing very quickly over the last decade. In terms of where we see machine learning today and AI today, as I've mentioned before, we're getting to the point where we can have superhuman computer vision perception. And again, that's very important in applications like robotics. We're seeing very rapid progress in natural language understanding and conversational AI with ChatGPT versions. We see a lot of progress in large scale, what's called self-supervised learning, multimodal learning. We're going to talk a little bit about that, where we're not only dealing with text data or language, but we can deal with videos and images and different other modalities. And of course, there's a lot of work happening in the space of bias, fairness, and explainability. How do we build systems that are fair? How do we build systems that are robust so that we can deploy, that technology in the real world? There is huge commercial investments in AI and machine learning today. Probably the biggest one is the space of large language models, natural language understanding. There is a big investments in that space, in particular in pretty much globally. So many startups are trying to build large language models and applications of large language models in different domains. But there is also a lot of investments in AR, VR space, so virtual reality, augmented reality, as well as in robotics and self-driving cars. There's also a lot of work in AI for public health and AI for drug discovery. And that's, both of those areas are of high priority for a lot of governments in the US in particular. AI for environmental sustainability, of course, that's another very big area of research and investment, commercial investments. And of course, privacy. Privacy is now becoming one of, biggest areas of research. How do we maintain privacy of our data, especially given all the success that we're seeing with AI today? And today's AI requires large volumes of data. That's sort of to train the models. ChatGPT was basically trained on the entire internet data, and so that's another sort of very big area of research. But let me show you, some of the progress. This is sort of shows you in 2014, when I was just an assistant professor at University of Toronto at that time, this is the faces that we were generating, right? And you kind of like see the progression in 2015, 16, 17. In about 2018, if you train on, this particular data set, these are the samples that, your model would generate. So we've been seeing very rapid progress even before, all the excitement that we see this past year. Over the last decade, we've sort of been seeing fairly rapid progress in AI. This is one of my favorite models. It was developed in 2017, 5 years ago. But this is the conditional generative model where you're trying to generate zebras given horses. Much like you would translate, French to English or English to Korean, here you're basically translating horses into zebras. Style transfer, given images, you can generate them in different styles. And one of the big advances that we see in AI today is the reuse of large-scale pre-trained models. Models like GPT, or in this case, this is one of the famous models called ResNet, residual network model. It's heavily used in computer vision. And what happens with a lot of systems today is that you train these models on large volumes of data, and then you reuse this model for some downstream application task. Like, for example, trying to predict, given a particular image, you're trying to predict a skin lesion, right? Whether it's a positive or negative. Of course, OpenAI's GPT-4 took everybody by storm, and ChatGPT, being able to build conversational agents, having question answering systems, information retrieval, code generation. A lot of that technology, again, has been improving rapidly over the last year, which is very, very exciting to see. Another sort of area of research that's been very popular in the last year are so-called diffusion models. These are all images generated by the model, right? These are not real images. And, there's been a paper just last year called Stable Diffusion, and you've probably heard about DALL-E models by OpenAI. Is basically, these are models where you're generating images from text data. And, you can give it some semantic mask, and it will generate this image. You can say, this is the sky, this is the lake, and it would generate sort of scenes for you. You can give it a natural description, like a fantasy landscape training on ArtStation, and it could generate sort of, these images for you. And again, that technology is developing very, very quickly. But in today's talk, I want to talk a little bit about a slightly different type of AI. I'd like to talk about two specific topics. One is the object goal navigation with embodied active learning. And the second one is grounding language models to images for multimodal generation. One of the things that I want to emphasize is that while we're seeing all this progress like ChatGPT and DALL-E and these diffusion models, a lot of them are, what we would call virtual models or virtual agents, right? Such as a conversational agents. But there is also a lot of work in developing physical intelligence. Now, physical intelligence, I think, is going to be the final frontier of AI or artificial general intelligence when you're actually going to be building robots, physical robots that are going to be acting in the environments. So, for example, given some environment, given some observation, you have a physical robot, and the physical robot might take actions. For example, if the robot moves around in the environment, the actions could be go forward, turn left, and turn right. And obviously, agents need to move around the world physically. Current actions will affect future observations, and it requires some form of spatial and semantic understanding of the environment. So in the first part of the talk, we're going to focus on building physical intelligence, building physical robots, and we're going to focus on specific task of building robots that can understand the surrounding environment and move around the surrounding environment. So there is a lot of work on what's called goal conditioned navigation, right? And a lot of it is relying on reinforcement learning agents. And the reinforcement learning agents, you can specify a goal. For example, a goal could be an image goal, and the model would be typically a deep neural network model that would execute a particular action, and you would have a reward. If your action were correct, you get a positive reward. If your actions were not correct, you get a negative reward. And that basically forms the basis of reinforcement learning algorithms within decision-making systems. And one sort of very popular application is language goal. This is where I'm interacting with the robot. I'm telling the robot what it needs to do, or I give it an instruction, and the robot would go and execute the instruction. And again, just to draw the parallels to ChatGPT, there is a lot of work right now asking large language models to generate instructions. And once you have instructions, you can give those instructions to your robot, and the robot would go and act in the physical world, right? And it's also convenient for humans, and you can there's a notion of compositionality when you interact with your robot with natural language. But let me show you one example. This is a simple example that we've developed at CMU. This is what the robot sees. This is what we call the predicted semantic map. This is a map of the environment that the robot is trying to understand. And the goal here is to find potted plants. So imagine that the robot moves around in your house and actually needs to find a potted plant. And here's what the observation looks like. Here's a little robot. It moves around in your environment. It analyzes the environment. It builds what we call a semantic map of the environment. And eventually it finds its goal location, which is finding a potted plant. Imagine building a robot that will go in and water your plants in the future, right? We just have to add an arm to this robot and it can sort of accomplish certain tasks in the environment. And one sort of general research area when we think about this is what's called embodied AI, because it's a physical robot that moves around in the environment. And one of the big challenges that we see today is that the type of data that we see from internet on the internet data scale is very different from the type of data that the robot sees. All right, because the robot sort of sees specific images as it moves around, and they look very different from what we typically find on the internet. So one of the biggest questions that we are asking here is, how can we build these agents, these physical robots that can move around the environment and that can learn from an environment on its own in what's called self-supervised way? How do we build agents that can learn in the environment on their own, much like children would learn? And if we use internet models for embodied agents, we typically get, this is a simulation where the robot moves around and it sort of tries to find a chair and it thinks this is a chair. And this is one of the state-of-the-art object detection models. Or if you're trying to find a toilet in this case, it misses the toilet because it's occluded. So how can we build more robust agents? And one of the notion that we're going to be pursuing here is this notion of persistency through time, right? This notion that as the agent moves around, if you see the sofa here, it's going to be here, and it's going to be here, and it's going to be here, right? As I move around, static objects stay in the scene over time. And we can use that information to build a better perception systems, or to build agents that can learn on their own by essentially using consistency through time. Okay, so there is very natural notion of what's sometimes referred to as perception action loop. And the idea here is that in step one, a robot or an agent would do exploration of the environment in self-supervised way. So it just moves around the environment, tries to understand the environment. And in step two, you would use self-supervised visual learning. So we try to improve your own perception system, right? So this is sort of, this idea has been around for the last decade, but I think that right now we're beginning to see more and more applications of these ideas. And so the goal would be to get the robot to learn on its own without actually human intervention, right? So how can we do that? Well, in the first phase, we're going to be building what we call active exploration policy. And the idea behind exploration policy is to build a 3D semantic map of the environment as the robot tries to understand the environment. And in the second phase, we're going to be training detection systems. In this case, it's a system called MaskRCNN, using spatiotemporal label propagation, or using what we call 3D label propagation in our environment. And what's interesting, both of these phases do not require any additional label data. So by moving around in the environment and by interacting with the environment, the agent will be able to learn to be better at recognizing objects, and it can learn to basically be better at building its own perception system. So we basically want to be able to build robots that improve over time on their own, simply by exploration and exploring the environment. So let's see how we can do this. Let's say here's an example. This is the first stage of building a 3D semantic map. So the robot here moves around. You're seeing, the observations that the robot sees. As it moves around the environment, it's attempting to build a 3D semantic map. It's trying to understand where you see the couch, where you see the bed, where you see the TV, where you see chairs. And of course, at this point, it's a toy environment because we only have 7 objects. And we've been collaborating with Meta to extend it to, having thousands of objects, right? So this is what we would refer to as a 3-dimensional semantic map, right? So now one question you would ask is, how can we build accurate 3D semantic maps? And what we do here is we use a specific type of reward function within reinforcement learning called gainful curiosity. And the idea here is that once we build this 3D semantic map, these voxelized spaces, we can sum them up across, sum across the length, breadth, and the height, and we count the number of voxels with 90% confidence. It's a threshold, and this now becomes our reward for the reinforcement learning algorithm. So our goal is to move around the environment and explore the environment in such a way that we can identify as many objects as possible reliably in our environment. And we train the system using, reinforcement learning algorithms to optimize for this objective, what we call, trying to maximize gaining definitive knowledge. That allows us to build the semantic map. Now, how can we improve perception of our system? Well, the idea here is that given our 3D representation, if the agent, if my robot, stands in this particular position, then I can get the labels for each pixel in the image by using ray tracing based on the agent's pose. So given what I'm seeing here, I can actually label these objects. And I can say what I'm seeing here is I'm seeing a chair here, I'm seeing another chair, I'm seeing a plant, and I'm seeing couches. If I take my state-of-the-art detection system, this was MaskRCNN system, it misses a couple of objects. These are false negatives, right? It's supposed to be a couch, but the model doesn't label. It's supposed to be a chair, and the model doesn't label it, right? So what I do now, essentially, I'm generating pseudo labels, or I'm generating labels on my own by simply exploring the environment, right? Because I've seen this chair from a different viewpoint in my semantic map. And now if I don't really see it from this viewpoint, I can use it as an additional training examples for improving my perception, for improving my visual recognition system. And you can see that by sort of exploration, again, this is a false negative. It thinks it's a chair, but that's not a chair. It's actually is a table. And so by sort of taking actions in the environment and learning in the environment, I can actually train a better perception model by using this notion of 3D label propagation, right? This becomes a fairly powerful framework if you scale it out, because what it's telling me that I can explore the environment and I create labels on my own, and I can continue improving my own visual recognition system, right? My own perception system, which doesn't require any human intervention. Imagine you have a robot, you bring it home and you leave it overnight. And your robot explores the environments, it's trying to understand what's there, and it keeps updating its own perception system, it keeps updating its own visual recognition system, and becomes better and better at recognizing objects in your house. And this is what we're seeing. This is some of the numbers. We're still quite far away from human level performance for this task. But what's interesting is there's been a lot of work on different algorithms, and you can sort of see you can think of it as a success rate. State-of-the-art model sitting at 34%, and pretty much all different variations that we've seen don't really improve that number. And with sort of this notion of moving around in the environment on this limited data set, we can actually improve the numbers substantially, quite substantially compared to existing, state-of-the-art methods. And again, I think that scaling these systems up in the future will allow us to build systems that are much more robust and that can basically learn on their own. Here's another example of, this is the physical robot moving around in your house. And what it's doing here, it's building semantic map. It's building where it can go, but it's not only that, it's also building, where's my chair, where's my bed, where's my couch, and where's the refrigerator as it moves around in the environment. This was also a joint work with Apple, and this is a little robot that they've built, looks like a little Wall-E, and it's trying to find a bed in one of their apartments, so you can sort of see it's having its observation, and it moves around. And the reason why you see this black sort of thing is that you have a person there, so we needed to de-anonymize the person. But you can see these robots can kind of move around, and eventually it goes and it finds, in this case, it's finding a bed. In a completely sort of new environments, it maps the environments and it finds a bed. And the next evolution of these systems is following instructions. So these are now becoming more evolved systems where I give you an instruction. For example, I give you an instruction of drop a clean pen on the table. And then it goes through a large language model. It creates subtasks. What does it need to get a clean pen on the table? And then it also has a view of the environment. It builds the semantic map. It combines, what the large language model is telling you, what the subtask you need to solve into the search policy, and then executes actions. So let me show you how it's sort of done. So for example, if I tell you, place a cold lettuce slice in a waste basket, that's my instruction to the robot. This is now done in simulation. And this is, in order to achieve this, the robot sort of has to move around. It has to pick up a knife. It has to slice the lettuce. It has to put the knife into the sink. It has to pick up sliced lettuce, open the fridge, put it in the fridge, and so forth. So there's a sequence of goals that the agent needs to execute in order to accomplish this task. This is, again, right now done in simulation because we don't have physical robots that can, pick up a knife and slice the lettuce at this point. But there is a lot of work on sort of building systems manipulation that can at least manipulate objects in the real world. Right, but again, these are the systems that we see a lot of evolution of these systems today, where these robots become much smarter by understanding having a detailed understanding of what the instructions mean and what that means to go and execute sub goals so that you can execute the final goal. And that's a fascinating area of research that brings together models like GPT, brings to foundational models from computer vision so that you can recognize objects, see objects, as well as foundation model from decision making, because ultimately you have to be able to take actions in the physical world and move around in the physical world. So very fascinating, very exciting area of research that we're going to see more and more progress in that space over the next 5 to 10 years. And ultimately, how do we build intelligent agents? Agents like GPT, ChatGPT, and GPT-4 and different extensions are virtual agents, right? And we've seen amazing progress in that area. And I think that the next frontier is going to be building physical agents, actually robots that can move around autonomously, that can plan, that can localize, that can have multimodal input. That becomes very important. So it's not just a simple text, but it's a vision. It's other sensory information like speech, lidar, all the sensors that self-driving cars have today. How can we understand human speech, reason, understand natural language? This is sort of again how we can and have some basic form of reasoning, right? As well as how can we build these agents that can take actions, act in the environment, and receive reward as they're accomplishing our tasks. Now, in the last part of the talk, I wanted to sort of focus a little bit on multimodal aspect. There is now a lot of work in building the next generation AI systems that, again, not just looking at text, but looking at multimodal inputs. So let me talk a little bit about how we've been thinking about building multimodal systems. So large language models, as we've seen today, like ChatGPT, are really impressive general models, right? They can code for you, they can answer questions for you. There's a lot of work on virtual agents where you can give an instruction and your GPT model will go and execute something for you, like send an email on your behalf. But a lot of these systems are text to text. More recently, we start seeing systems that can take text and image and then goes to text, right? GPT-4V, where V stands for vision, now you can upload the image and you can ask questions about that image. But we've been thinking about how do we take these large language models and how can we ask them to consume and produce visual data, right? So how can we take, an open source or pre-trained large language model and sort of align it such that it now can deal with visual data, right? And this is something that we've been working. So here's an example of a multimodal dialogue, where I can ask you, what is this? And, the system will tell you it's a particular type of a bird. I can ask more questions about it. And if I ask me, show me the pictures of these kinds of birds, the model will basically retrieve or generate images of these birds, right? Or I can take, an image and I can say, give me this image at the lake, or give me at the beach, or give me in the forest, right? So it's this notion of compositionality of images and text, and also kind of like being able to generate these multimodal dialogues where I can just not only provide the image, but I can also generate and retrieve the image in a natural way. And so how can we do this? Well, we can leverage the abilities of pre-trained text-only large language models, models like GPT 3.5 or like ChatGPT. We're building models that are model agnostic. So for example, in our case, we've been using a 7 billion parameter llama model that was released by Meta. The algorithms that we're designing are simple and efficient. We can basically train these systems on a single GPU in 24 hours to achieve this effect. So let me quickly show you what the underlying structure of these systems are and how we train these systems. And this is probably going to be the most technical slide that you see in this presentation, but let me just give you a high-level idea of what we're trying to do here. one of the key ideas that we've been trying to think about, how do we take these large language models and make them multimodal, is we're going to be outputting a specific token called retrieval. So for example, if I give you an image and I give you the caption, if I pass it through the large language model, the way you train large language models, you predict a one word at a time, right? You're predicting one token at a time. And what we're going to do here is we're going to predict the token retrieval. So the model can learn to retrieve images. And so this is done through cross-entropy loss. This is a standard training of large language model. But then we also take the image, we use the visual encoder, and we're using what's called noise contrastive estimation loss, which essentially is trying to map the representation of this token to the representation of the image. At the high level, what we're doing here, and pretty much other models have been doing the same, is we're essentially trying to bring this image into the large language model space. All these models are operating on some feature space, right? They're operating in high dimensional feature space, and we're just trying to align images and sentences and bring them to the same space. And that's sort of a very powerful idea, because that's the idea that underlies a lot of multimodal systems, where I can take speech, I can take images, I can take video, I can take sentences and text, and I can all embed them into the same sort of feature representation space, because these are all vectors that lie in 4,000 dimensional space. As long as I properly align them, I can create fairly powerful algorithms. And so we've been sort of, after training this model, we can do interesting things. So for example, we can do contextual image retrieval. Given a visual story, retrieve the correct image. So for example, if I, give you a visual story, I give you the sentence and the image, the last sentence, can I retrieve the correct image? And you can sort of like see that these models, they do reasonably well. I mean, the numbers basically say that they beat a lot of kind of baselines, and a lot of them are based on the CLIP models that was developed by OpenAI. We can also do visual dialogue. So for example, given the image, I can, ask questions about this image. And it's exactly what GPT-4V is now doing at the scale. These systems are scaled. Or we can retrieve the correct image given a series of dialogues about it. So for example, I can, have a conversation with you, with my large language model, and then ask the model to retrieve, the image, or to generate the image that's consistent with my dialogue. And again, we're sort of seeing these models are doing reasonably well. And again, these models will be better and better over the next few years. So here we can answer questions about image given the past dialogue discussing it, or I can retrieve the correct image given the series dialogues about it. And what's interesting in this notion, perhaps just one thing to remember, is that the multimodality is very helpful. So this notion is, if I give you more information about, with images or with videos and the text, and here's, we're basically seeing that our performance improves if we give you more context. So it sort of has this notion of, the more information, the visual, textual information you give, the better my results will be. Okay, so that's kind of one thing that I wanted to mention. And we've extended this work to generating images with large language models. So we've developed a system where not only it can retrieve the images from a fixed database, but it can also generate the images. So for example, I can give you that image and I can say, how can I make this more nutritious? And the large language model would say you can add vegetables, ramen noodles, but you should be careful not to overdo it. And then your bot, your chatbot, basically generates the image. So it generates the image of more nutritious food for you. This is not retrieve, this is generate. And you can ask them, what are some vegetables I can add to it, and it tells you what they are. And again, there's some tattoo ideas, there's a publicizing cupcakes. You can kind of like upload the images. How should I publicize these in the market? It can tell you what it is, and it can generate, based on that conversation, it can generate the images for you, right? And again, this notion of building multimodal systems, I think it's going to be, again, the next frontier. Physical AI, building physical agents interacting in the real world, as well as this notion of accepting multimodal and being able to reason in the multimodal space are probably going to be the next big sort of evolution of AI, and will probably get us closer to artificial general intelligence as we build these systems. And we have the mod online. You can sort of try it and see how it works. It's fully open source and so forth. So it's very very exciting times to be in AI right now. And I think my talk is coming to the end. So thank you very much for the invitation. And I just want to thank my amazing students. And again, I just wanted to emphasize a lot of students at CMU actually come from Seoul, from Korea, like Tiffany, an Apple fellow. She's been developing, and Min Ji Yoon, amazing students coming from Korea to do PhD studies at Carnegie Mellon. So thank you.
Please give him another big round of applause, ladies and gentlemen. Thank you very much. Thank you very much, Professor, for setting the tone of today's forum. And now I'm pleased to invite the next keynote speaker, Dr. Soa Park. Dr. Soa Park is the Vice President of Vive Company. She will give a presentation on the topic AI and data utilization in the public sector. So please welcome her with a big round of applause.
So it suddenly got cold, but nevertheless, it's a great pleasure and honor to be providing this keynote speech with so many guests here today. Well, this morning, it's not because of this lecture, but anyway, I received a text message at 6 a.m. What do you think it was? Not weather. It was not weather. So it was a congratulations, birthday congratulations message. So because, Kakao Talk posts my birth date. So, and also Google analysts said, you tend to like these things on your birthday. So I got a list of birthday present recommendation by Google. So anyway, after all of that, I came here. So I am going to talk about AI today, but I've worked 30 years in the public sector in e-government, and also I'm now working on digital platform initiative, and so super AI and digital twin-based permits is my area of work. So today, what I would like to talk about is, so we've had the previous keynote speech about multimodal algorithms. Well, I want to talk about how these technologies can be used in the public sector in the form of service. So that is the theme of my speech today.
전체 이제 발표 섹터는 한
So my talk consists of 6 parts. So most of my speech will be focused on the front part of this agenda. So we're going to talk about data. So last year already, we talked about artificial intelligence. We heard from the keynote speech from Chairperson Kim Bok-chul. But anyway, we think AI is important, and we think AI is important for our daily lives and science and technology. But what I want to say is, well, personally, I want to be a science and technology person, and when I retire, I am going to go into a science and technology village. I have the authority to be in that village, so I'm very proud of that. But anyway, in the public sector, I have dealt with many big data, AI, and twin platform, and super AI, mega AI. And there were always the question of data. We say collect data, but people ask why? Why do we collect data? So to that, I've always said that data is a puzzle piece of reality. So in fact, as the chairperson mentioned, data quality is actually maybe more important than technology itself, and because data is like the seed for developing and growing the AI technology. So when we talk about artificial intelligence, we talk about a specific technology in a specific domain. However, if we have quality data, we are able to complete the puzzle. And I think AI is a facilitator in us creating and completing that puzzle. So that is the background of my presentation today. So it is a pretty picture, right? So this is the Gyeongbokgung Palace in Korea. So, there are many, some people may know how Gyeongbokgung was first designed. Uh, so Lee Seong-ge was the founder of the Joseon dynasty, and he was very interested about how he runs the country. And Chung Do-jeon was a scientist and a scholar at that time, and our founder of Joseon dynasty asked Chung Do-jeon to design this palace based on science and all of those insights. And that this is the map of Gyeongbokgung Palace. So you'll see this at the in front of the palace. And there are many versions, but I brought this here because I want to talk about how the countries are ran based on policies. So there's a policy side and the operation side of the policies, and that is reflected in the map of this Joseon dynasty's Gyeongbokgung Palace. So Sajeongjeon is where the policy process took place. It was the executive office, and all the execution happened in Kunjeongjeon. The operational process happened in the throne hall. Especially, you may know the Sejong, the great king who created Hangul, and actually, Sejong put a scholarly wing beside the policy process so that all the studies and theses could be used for making policies, and that helps us understand how the king put importance on data and policy. So I want to go back. So, making policy, the policy process does not just simply mean, developing policies and just implementing it. But actually, what's most important is at the bottom of this map is the second inner gate, Hongnaemun. So it means that the policy is made and is implemented and is implemented and sent out to the public through this gate. So this means that the policy does not end inside a research center or a government. Once the policy is made, it has to be made known to the public, and then it needs to be reviewed and assessed. And that is why I like this picture, because it seems to represent that process. So I posed a question about data. Why is it important? So when you think about data, so if we compared this to, the policy-making process, do you think people can, do all that calculation? Lee Se-dol, right? The famous paddock player who competed with AlphaGo. So at the time of that game, I was on a business trip, and I got a call from the government personnel, and said that, okay, so procure 30 billion so that we can make that kind of system. So I got that subsidy. Of course, we were not able to put it into actual use or a project, but anyway, if you think about the human brain, there's some limitation to it, and big data can support human brain. So we need to make the right policies, and I think AI could assist that process of, having the data set being utilized by our brains. And also, as mentioned in the previous keynote, there are many algorithms that can be used for us to simulate a policy to see whether this policy is good or bad. And after validation, we could actually enroll and implement that policy. So if we could use AI and data in that process, I think it would be very helpful. And I think it will help people understand better why big data is important. So if we filter out the big data well enough, we'll be able to use the data for all the policy making and the development. And based on that, we could, deduct the AI and algorithms that we can actually use for policy creations. So now, why do we need to use AI in the public sector? So I think we need to first look at the environment first. So digital environmental change, we all know is happening, that the environment is changing. So, there was a new normal, but now there was, low economic growth and high interest rate. And, all of these are very hot issues these days. And, there were always issues in any new normal ages. But, at all of the times, these scientists here created some good policies, and we were able to resolve some of these issues with those policies. But if you look at the government now, and if you look at the new trend of this new normal, well, it's getting more and more difficult to predict. So the reason I'm mentioning this is because we have AIs and we have different technologies, but they need to be used not only to resolve the issues we have now, but they need to help us resolving the unpredicted issues going forward. And also the public, they are asking for innovation, but not just technological innovation. They want innovation to be embedded in the services that we receive too. So, the issues are changing. We're encountering new issues all the time. But these technologies need to help us so that we could flexibly address these issues. That's what I wanted to say. And also, secondly, we need to acknowledge that the environment of the users are changing too. So if you look at the people here, you could see you could both do, online and offline, right? Considering our age. But when we talk about the MZs, and if we think about the digital natives, the young generation, they only do mobile. So the tools they use are different from us. We used to use desktops, laptops, and you use various terminals to use services. But now the younger generation only use the mobile channel. But nevertheless, the government, if we release a service or a policy, then we make sure that this service can be provided through all the channels. Of course, there's a reason to it because we want to make sure that nobody is excluded, and we want to make sure that the people who don't have access to the digital means can also access these services too. But the thing is that most of the users nowadays use mobile channel, and that means that we need to have a new communication channel, and that is a big challenge for the government, that we need to change the way we communicate with the public. So that is why we want to promote the digital platform government, and we have the science people here. But we talk a lot about data-driven scientific administration. But anyway, we talked about AI, we talked about data, we talked about technologies, and we need to use all of this in order for us to make sure that we have a data-driven and sustainable scientific administration. And to make this possible, data is not sufficient. We need to have institutional innovation, and also we need to have the technological development to support all of these efforts. And that is why, again, AI big data is important. Next, I want to talk about the emergence of digital platform government in Korea. So the new government said they will shift to a digital platform government, and the current government is releasing many roadmaps.
인공지능 그리고
Basically, AI and big data is the starting point. And we think that artificial intelligence and data is a new opportunity for a new leap for the Korean government. So all kinds of data will be converged with this new digital platform. And here, the government, the companies, the public will be, joining hands to solving issues that we will counter. And, in this trend, new companies will be benefiting from it. They may be making profits, and that is actually what we are aspiring to do with this new digital platform government. So there are 4 key strategies that were announced on April 14, 2023, and some of the actions are already in place. And at this point, we have got the budget to implement these 4 strategies and action plans. And in order to thoroughly manage these, we have created 17 tables or checklists so that we can implement these strategies more accurately. So the aim is creating the world's premier digital platform government with artificial intelligence and data, and these are the 4 pillars. So inside these 4 pillars, one of the key priority for us is for each of the sectors, mega AI innovation will be promoted. So there are too many details, so I just want to talk about the policy that deals with mega AI. So as you could see on the action plans, So we want to create the infrastructure and the ecosystem to enhance Mega AI. So that is one point of this implementation strategy. And to make this possible, so we will also think about how this Mega AI can be used in the corporate and the private sector. And so the government-led POC has been created, and 200 institutions have participated in this. And this project will end at the end of this year. So we're getting a lot of interest, and we are already seeing a lot of success. And from the government's perspective, the biggest issue of the Mega AI could be the closed loop, meaning that this data can only be used within inside a certain pool. So we are also checking how it could be shared with a bigger public. And also we want to use Mega AI to enhance the efficiency of the services too. So all of these are included in our strategy. So our digital platform government has about 3 use cases that we have shared with the public. First one was the benefit informer that automatically tailors deliveries. So it could sound very complicated, but what's important is that it does this by itself. So all the benefits are, the tailored benefit messages are sent out to the public. So these kind of services already in place in the market. But however, the government wants to make sure that very minor, things of the citizens are recognized and acknowledged by the government. And this benefit informer will be launched probably next year. So I told you that it's my birthday today, and I think this benefit informer is a bit similar to that customized birthday alarm. You know. So the next use case is the zero attachments of documents to government offices. So we all know that we need to submit a lot of documents to the government for any of the services that we want to use. So it means that we want to save the wasted time. So the time you waste submitting documents, and also the government seeking to making paperless document too. So, by reducing all the physical document submissions, we could save about 2 trillion won per year. And, there's a lot of, digital initiatives like My Data and so on. But the thing is that still, if you go to the local government level, these offices still require paper documents. And the government is seeking to eliminate all of that. And the third use case is factory simplified permitting service. So at the digital platform government initiative, so I was asked to make the first report last week, and this is what I reported on. So digital twin technology will be used here. So which is like the epitome of the AI technology. So a lot of social issues will be able to resolve because there are a lot of intermediaries and brokers in the middlemen, so-called, right? So so there were cartels, but last week we met people at the local government and the local business sites, and they said that saving time is more valuable for the companies than saving money. So a lot of people said saving time is more important last week. So just providing technology as a service is not enough for them. So the companies and the citizens want to be able to save time. And if our public service, if our AI-based service can do that, then I think that would be very meaningful. So there was a lot of like one-stop services that we have rolled out, but anyway, we want to make this more feasible so that the people on the field can actually feel the benefits. So if you want to set up a factory, you need to submit a lot of documents, and you have limited access to experts. But then the digital platform government will be recommending expert list, and will be eliminating a lot of incumbent or tedious processes in setting up these factories. So these were the use cases that we are using to talk with our public citizens. So next is about the AI and data utilization in the public sector. So I think the hottest issue is the Mega AI. So, and also generative AI. So a lot of companies already use generative AI. but we want to implement this in the policy sector too. So, and that is what Digital Platform Government Commission is doing. So at the end of last year, we used the Mega AI or generative AI to create minutes or the meeting materials. So ODT is a text-based document. So this ODT is a document format not tied to a specific software, but it's a form that the machine can read, and we are making continuous investment so that we could expand this technology. So there is no technological issue in rolling this out, but there will be some systematic issues because a lot of data inside the government, if it is fed into the generative AI, then all those internal government documents or information may be open to the private sector. So this is the major issue that the government is seeking to address. And in case of Gyeongsang-Buk-do province, well, I actually participated in one of their meetings, and Gyeongbuk province is the first government to use ChatGPT in their administrative processes. And there are a lot of R&D centers in that area have participated in this project initiative. So the ChatGPT is used very proactively by this government. And also, we want to be able to use generative AI for education too. So a lot of local governments and these education-related agencies are provided with a playbook so that they could use AI better. And I want to share some case studies. So I've talked about the macro level AI initiatives, and now I want to talk about what the government actually has been working on the past 4 years. So we have created 76 big data models and came up with these use cases. So there were a few actual examples that were implemented last year, and I want to introduce just 4 of them today. So one is improving the detection rate of fraudulent claims. So as you well know, because of COVID and because of all sort of things, the government is providing a lot of subsidies, and the government wants to make sure that they provide the subsidy to the right people, and also they want to make sure that the government does not provide the subsidy to the wrong people. So AI can be used to filter out the applicants. And second case study is the early detection of local government conflicts. So this is about the early warning service that we have been working on this for the past 3 years. So the ICT emergency is they are working on how they need to work on the emergencies, but the local governments also need to talk about what kind of repercussion it could have on the social society. So because people may have complaints about the policy, so they might do demonstrations, they might oppose. So from the local government's perspective, they are reluctant sometimes to implement the policies. We can use the social data to detect these potential conflict between the government and the local government before rolling out a policy. And third, about activation of regional tourism. So every year,
관련된 부분들을 분석도
there are regional festivals, and people think about what we're going to do next year. So all of this are put into a database, and we have created a huge data set based on these regional and local festivals. And this is utilized by the local governments, and it is actually helping in boosting their economies too. And this is also about the emergency relief, so I will skip because it's similar to the previous case.
이제 말씀
So from now on, I would like to go through about how EAI is utilized both domestically and internationally. And I've also done some research about the recent data. And so I've looked into the US, EU, and Korea. And the scope of services and the starting point were not much different between the countries. But as you can see in this slide, for instance, in US it's 45%, and Korea it's 55%, saying that they are thinking about utilizing AI. So it means that all the countries had the policies in place to utilize AI. However, in terms of utilizing AI actually differs across countries. Can you see the difference? So I've received this data from a researcher, and I've been making thoughts. Oh, it looks similar because 50% level is all quite similar across the countries. For instance, in the U.S., AI is utilized with a primary purpose to do regulation research, to do analysis. So they use 50% of the AI technology. However, in Korea, AI is utilized for public sector services, and so 51% is used for public services. And for analysis and monitoring and for internal management, the level was only about 15% to 20% level. And so the biggest difference between the US and Korea would be the specific details that we saw earlier. In the US, for instance, US uses AI because of the needs, internal needs. So there were internal needs to utilize and use AI. And because of those internal needs, the employees wanted to use AI. And they also did the development, also the analysis of the AI technologies. And that level was 53%. However, in Korea, it's in the other way because there are many other companies that actually do the development. And when the government says we need AI, then there are these companies that will do the development and do the analysis. So that is the picture in Korea. So we need to make further thoughts about AI and AI services, meaning that there could be many errors to do the actual evaluation of AI. So the core and gist of AI should be evaluated by the users. They should be thinking about what differences or what challenges there are in using AI. And in terms of sustainability and consistency, and also looking at these results, voluntary participation, and also if there are like public institutions or researchers, because of the need, they do take part in the development. So I think this is important to do voluntary participation. And so this would be the overall direction of the AI policies. In the US, for instance, many federal government agencies are widely using AI, but only the level is less than 50%, so around 12% level. So the technology is not only important, but it's also important to know what are the difficulties, to do the brainstorming, to find solutions to problems. And with that, their capability and capacities will grow, and that is the process. And then I believe that technology assisted about 12% in that process. So I believe that this would be a significant portion. And then the policies that will come out of that process will be good policies. And so, considering Korean cases, I believe that also in Korea, public sector and R&D as well. In turn, AI should be used by the internal users, by internal development team, and should be used to foster the human resources. And I think this should be the preparation that should be done in Korea. And the next session is about AI and Vive, our company's data system. And I would like to show you briefly. So regarding AI, I've mentioned a lot already, but just to briefly explain again, we were a spin-off from Down Portal, established in 2000, so we've been in the market over 20 years. And we try to read people's minds through data, so that is our catchphrase. And until now, we've been leading in the big data and AI technology. We are still a small company, but with the big data technology that we had from Down and also the search engine, now we are creating solutions for hyperscale AI. And also we are with Naver, KT, and Down and Vive company. We are doing the project together. And so regarding that project, and you can also see in chronological orders, so we are currently working on the hyperscale or large-scale AI language model, and we've been also carrying out big data and digital twin reports and been providing those reports. And these are the concepts of Vibe services regarding data and AI. And so when data meets AI, then it can solve problems, and the critical values and insights can be derived. That is the main concept of Vibe service. And in that process, to experts, to people, the ability to find the right decision will be provided by AI and data. And so there are 4 Vive solutions. So we have the intelligent search engines, the Vive search engines. It is based on the LLM models. And also we as for end of last year, we have done the MRC model, and the accuracy level of the MRC is also quite high. And the next is about the Vive report, the Vive summary. These are other areas that we do. And I would like to briefly explain a little bit more about some trend that is used a lot by other research institutions. So I said that we have a history of 20 years, and we have a lot of data, vast amount of data, just like Google. And it is mainly focused on social data. And so what we can do with that social data is, so anything that we cannot check from the structured data, we call that insights or understanding. So in that process of understanding, we can do some assistance. And in that process, we can see the trend of the social media or the thoughts of people. And we can also see the behaviors of the people. So with that social data, we will analyze big data. And then we also provide services, and that is the portal called Some Trend. And since we are accumulating data, and so there are about 45 billion data that we already have, and we are currently making the system even smarter. And so generative AI is also based on that data, and that is why it was possible to be developing that fast. And I said that we are the only one. We are Korea's only high-volume big data analysis provider. For instance, if there's a company selling cosmetic products, then before they launch their products, then the company will ask to us to analyze those comments. And so I would like to share this interesting case. There was this cosmetic company, and they launched a product, and then they saw our report, and then they contacted us, and they said, we should get rid of this. Why? It's because one of the comments said, so when we read the comments related to trend, then we can see the consumption trend of the younger generation, because they are the ones leading the market. And of course, they get the money from their parents, but they are the ones who are actually spending the money. And so the people in the teenagers and people in their 20s are the ones who actually buy the products. And then they said, oh, these products look a little bit old. They feel old. So although they are teenagers who are in their youth buying those products, but they said that this product relatively feels old, and that is why the company had to make some revisions to their products, changing the fragrance and so on. And so this shows that people are sensitive to trends. And for those consumers sensitive to trends, products analyze the behaviors of the consumers. And this is very important for marketing, and that is why the private sector uses our platform for the marketing purposes. And we have similar services. For instance, when the COVID pandemic broke out, we were one of the first to have these analysis reports and provided it to the government. And especially if you watch TV news, then you can see that this was the result of Vive company. And also in terms of policy, all the policies of the 49 government institutions and agencies, we also do the analysis of those policies. And also, this is a material that is only accessible to the public servants. However, I'm just telling you that we have a lot of data and report that is being provided and published every week, every month, and that is being widely utilized across the government. And also when it comes to financial frauds and also relevant financial institutions, they also receive a lot of technological assistance from us. And also we have a lot of big data centers as well. And so that was the introduction to our company. And next, I would like to give you like a solution. So you might think that AI is a tool for innovation, and that is why you are here today. And so there are many opinions about that question, whether AI is really a tool for innovation, but I have prepared about 3 slides to explain. And so after the launch of AI and ChatGPT and all those relevant technologies, there are people who produce knowledge, and they're not So we no longer have to make a lot of efforts to produce or learn. And you are researchers and you do a lot of research. And when you compare the time, how much you spend to do the research, you can see that you can save a lot of time in doing research. Of course, there's bias, hallucination. There are still some limitations and restrictions in using AI. However, we no longer have to make a lot of efforts to find knowledge, to do the searching. And that is the, I think, biggest change that we face these days. Next slide. And next is about, in order for AI to become a tool for innovation, we have to do well, especially in terms of policy. We have to do well. And I don't have to stress it again. We all know what we have to do because there are side effects. For instance, these days in the media focuses more on the side effects rather than the positive effects. And of course, these can be hurdles of the technological development. However, we still have to work on this area. And that is why somebody has to work for this field, which means that all of you, I believe, are the ones who will have to work in this field, nevertheless. And if the technology advances, then what does the human do? That would be the eventual question. But then after we have seen the development of call centers and AICC, AI chatbots, so do you think that we have less human workers? When you look at government reports, you can see that there are more people actually working in call centers. So even if the technology develops, still there will be human roles and the decision making will be done by humans, and that is why all in all, it's about how to wisely use AI. This would be the gist of all this process, and that is why it's important to be competitive in this field. And I would like to talk about my last part of the presentation. And so I would like to ask you the question again. Whether we can read the minds of people with data, do you think so? Can you raise your hands if you think that is possible? Okay. I believe that with data, we can read data. We can understand people's minds. And so I've done a research about the millennial generation's lifestyle and job perception. For instance, the millennials are the ones in their 20s and 30s. So we have this sort of understanding about the MZ generation, about the youth. So whenever I talk about AI and big data, I always talk about these generations. And this is more like a keyword analysis. And so when you talk about Gen AI, there could be many more interesting stories. But with these keyword analysis, we can see what the difference of the 20s and 30s people are. And so the people in the 20s and 30s, we thought that they would do a lot to achieve what they want to do. But for them, it actually came out that cost was very important. Although they are hardworking and they express their minds, opinions a lot, but still within themselves, they think a lot. They're worried about their future. They're concerned. They're also concerned about costs and everything else. And so, of course, I cannot say that these keywords are the really answers and represent everyone, but we can see this data. We can understand the facts, and then when we meet these people and we talk with them, then we can create the relevant policies for them, which would be a much more meaningful policy because we have these keywords that are in their minds. And I think this pretty much summarizes everything that I want to say. When Professor Imina was running a research center, this was a basic approach. In Korean, it would be 천지인, meaning which would be the relationship between time and human, and so what technology and space and what technology should be used. And I believe that this provides answers. It's not easy, but science is not only about solving our nowadays problems. So the data that we accumulate, the technologies that we will develop, all of that will be used to solve societal problems, for instance, demographical problems. So because we are living in an era where there are numerous problems, and so I believe that we should have this kind of approach with science and use AI and data, and then we can have a brighter vision of the future. So this would be the end of my presentation. Thank you.
Round of applause, ladies and gentlemen. Thank you very much for your insightful presentation, Dr. Park.